Good day to all of you. My name is Jens de Boer. The next 10 minutes, I will be taking you through the Simcenter portfolio, which brings together all our simulation and test solutions. While doing so, I will share a number of examples on how we can contribute to spacecraft performance engineering and help you launch and evaluate the performance of your products before building them. We will kick off with a short look at the space market. After that, we will introduce the various physics inside the Simcenter portfolio and show you how together they provide value when solving engineering problems. But let's take a look at the space industry first, which is booming by every single metric you can take. And I've taken an extract from a McKinsey report to illustrate that. For the webinar today, it's important that we have a look at the increase in satellites and the increase in startups, while in parallel, we have declining costs for satellite development and launch. This means that the space industry as a whole is becoming more competitive. Startups need to launch faster and are rethinking the way they use simulation and test as part of their overall development process to achieve that. On the other hand, established companies are pursuing new activities and need to get their satellites in orbit faster and at lower cost. This is again an area where an intelligent use of simulation and test can help. Simcenter as a portfolio is well positioned to support the booming space industry, as it provides both simulation and test capabilities around a wide range of physics: structural, fluids, thermal, electromagnetics, acoustics, and chemistry. In the context of spacecraft performance engineering, it allows us to cover a wide range of applications: propulsion performance, structural, thermal, and robots engineering, electromagnetics performance, testing, verification, and qualification, and also safety and mission assurance. We typically articulate these applications in around a number of values. We allow to increase decision-making confidence by front-loading simulation through automation and standardization. We also improve insight by exploring the possibilities through DSE or through combined use of simulation and test. We can innovate faster by maximizing engineering value, thereby improving speed and agility. And we assure our simulations are credible through linking them with test and the wider program, like MBSE or verification management processes. As a first topic, I'd like to illustrate how credible simulations are performed in full alignment and in a traceable way with test, and how this can help accelerate the qualification testing process. The first way we assure credible simulations is by bringing together simulation and test like nobody else. Historically, we have had a strong position in structural dynamics, both testing and simulation, and we have invested in solutions that help to both do upfront de-risking of the test and also correlate results afterwards. We have also recently led the way in reducing the cost of acoustic qualification testing by bringing to the market a set of simulation and test products that enable direct field acoustic noise testing. For people who want more information on that topic, I've put a link to a blog here below where we explain what we've done in that area over the past years, and also how we have recently performed a direct field acoustic test on our Leuven premises. Very interesting blog. We continue to mature this hybrid use of simulation and test, allowing us to move, as described here, to a more simulation-driven product development way of working, where targeted tests are done to validate the simulation-driven approach to building a product. We have the solutions in-house to support the deployment of a credibility assurance framework that allows to move to this more simulation-driven way of working, as described by Dr. Javed Fatemi from Airbus Defence and Space in his paper on building credible simulations for qualification of space launch vehicle structures. As a second, we will illustrate how we increase decision-making confidence by front-loading simulation through better automation and standardization of tools and processes. The application we selected to do that is run from NASA Goddard, and it talks about spacecraft safety and mission assurance. It talks about how a consistent, shared, model-based analysis tool for reliability, availability, maintenance, and safety connected to the systems engineering world helps to understand the way in which a product fails a lot faster. It describes how several failure analysis reports generated from a single model greatly reduce the overheads in doing such analysis. Ultimately, this leads to an increased confidence of the product through a faster understanding of failure modes, a better understanding of the effect that these failures have, and the criticality that they have. For people interested, I've also added the link to the webinar from NASA Goddard on the slide. I can recommend to follow it. As a third value, I would like to illustrate how we help exploring the possibilities by combining different engineering models together to represent the complex physical behavior of a system in a better way, thereby understanding the way in which the system behaves far more in depth. An example of that you see here, where we predict the deployment and positioning of the solar antenna of the satellite through a mechatronic simulation, connecting multi-body simulation for the dynamics of satellite to a system simulation model for the power actuators to a control simulation for control optimization. The value lies therein not to optimize each of the subsystems separately, but to treat the system as a whole and optimize it as such. And that's something that the Simcenter portfolio allows you to do in an efficient way. As a last value point, I'd like to talk about how we help innovate at a higher pace by removing non-value added engineering tasks. An example of that is given by Mynaric, a company that develops laser terminals to provide secure large bandwidth communication. Mynaric creates detailed simulations using Simcenter that accurately predict thermal and structural performance of their laser terminals, which is critical to understand if the positioning of these laser terminals will be correct. By deploying Simcenter, Mynaric eliminated the use of using separated simulation products that require complex and time-consuming rework of the models to share information amongst them. This allowed them to reduce modeling time by 83%. Ultimately, they will, because of this change in process, be able to put this product on the market faster. For those interested, please also check the link to the resources we have on our website describing in full how Mynaric is using our tools. To conclude, I'd like to emphasize that simulation and test is an integrated part of the accelerator portfolio, backed up by our support and services organization, allowing us to deploy positive change at scale. I'd also like to remind interested users that we have a user group meeting on Simcenter 2D coming up in Denver on the 19th. For details, please contact Catherine Hork at the email address provided on this slide. Thank you very much for your attention.